Bismillahirrahmanirrahim. So today's topic is components of a computer network. Components of a computer network. Uh, the topic is, very simple, and it would include things that are of interest to most of the people, no matter they are into studying something that is related to computer organization or networking. Rather, that would be, of interest to most of the people uh, that are using computer and the networks in their offices and in their research also. So definition, a computer network is defined as the interconnection of two or more computers, right? So we have a computer and then we have another computer, and we have some kind of interconnection between at least two or more than two computers, right? So that basically is a computer network. It is done to enable the computers to communicate and share available resources. So why do we need a computer network? The first thing is that the computers need to communicate with each other. And the other thing is that they want to share available resources with each other. So what are the applications? The first application is sharing of resources such as printers. You must have seen that in office spaces, you have a number of computers, a number of sub offices, a number of desks, and there is one printer installed, and all of those computers are sharing that printer. So obviously, you need to establish some kind of computer network so that everyone that are sitting or connected to that printer can use that printer, and that is how you share one printer with a number of resources. Point number two is the sharing of expensive software and databases. So again, you buy some kind of software and you want that software to be used by a number of people. Again, you need to share your resource, or one computer needs to share the resource with other computers, and that is the other application of the computer network. Point number three, communication from one computer to another computer. Obviously, especially in the office spaces, there are a number of computers that are connected, or you can say that we have some kind of query that is, fed to a company that is bound to, having a call center. So the query should be displayable to a number of computers, and then one of the computer needs to handle that. So obviously, you need to have some kind of computer networking between the computers. Point number four is the exchange of data and information among users via network. Obviously, this is something related to the point number three. And point number five is sharing of information over geographically wide areas. This is a very important thing, that computer networking is not just confined to a limited space. Rather, obviously, there is no boundary these days. So geographically wide areas will have the computers, and obviously they also need to communicate. And by that, you need to have the share of information over a wider network. And for that, again, the computer networking comes into play. The use of computer network. It is used for the business applications, such as online buying, for home applications, such as mails, chats, by users like wireless, laptops, personal digital assistants, mobile, and plane, social issues. All of these things require computer network. Okay, so the sharing of information, what can be that information? That is the data communication. Do you prefer these? So, or this? In this thing, you can see there are two computers, obviously looking like quite old computers, and both of these computers are linked to this sort of file that looks like a floppy disk was, but that is, you can say, some kind of file. Or do you want to share information like this? For example, we have a network like this. We will shortly see what are the differences between how you share the information with the other system. Sharing hardware or software, for example, print document. The next thing is the centralized administration and support. For example, the internet base, so everyone can access the same administrative or support applications from their PCs. For example, you use, learning management system. So I have a learning management system. For example, I upload all the stuff related to this course on a central system, and the other students that are enrolled into this course can get access to that, right? So even my learning management system is then connected to a centralized server. Components of a computer network: two or more computers, cables as links between the computers. We have a network interfacing card on each computer. We have switches, we have software that is called the operating system. So all of these things are necessary in order to make a reliable computer network. It's not that just we have two computers and that's enough, or they are connected to some kind of a cable. Obviously, there are a number of other things. The network interface card, switches, the operating systems. Benefits. The network provided to the users can be divided into two categories. The first is the sharing, and the other is the connectivity. The type of resources are the hardware. A network allows users to share many hardware devices such as printers, modems, fax machines, CD-ROM players, etc. And software, the sharing software resources reduces the cost of software installation, saves space on the hard disk. For example, I intend to use some kind of a software that is not installed on my system. So I just, log into my system and get access to the system that has the software installed in that. And, via the networking, I can make use of that software. So by that, I'm not only saving the cost that I would have to face in order to buy that, but also the space. I don't need to have uh, that software installed into my personal system or the hard disk that I may be using. So this is another advantage. Other benefits of the computer network: there is increased speed, many applications, reduce cost. Regarding the speed, I must say, these days in most of the institution, there are, as a sort of a lab is set up where there is sort of high performance computing is performed, where there are a number of GPUs installed in there, right? So the employee has sort of access to make use of that high performance computing lab in order to use the GPUs installed over there, right? For example, if I want to run some kind of machine learning algorithm which has lots and lots of data, right? And I need to perform that on some software, right? So I can get access of that high performance computing lab via my laptop that is available to me. And I can run the algorithm that I develop on those high performance computing computers, right? The other point is the reduced cost. Obviously, if you have networking, if you have, spent some money on one good system, and that good system can be used by a number of other users, obviously you're reducing the cost. You have improved security. You have centralized software management, electronic mail, and flexible access. Obviously, these are quite obvious benefits of a computer network. What are the disadvantages of networks? Okay, regarding the disadvantages of network, the first one is the high cost of installation. Number two is it requires time for administration. The failure of the server and cable faults. These are a few of the most uh, major disadvantages of a computer network. Obviously, you need to bear some cost in order to come up with a computer network. And obviously, it requires time for administration of the overall network. The failure of server obviously can affect a number of systems that are connected to that computer network. And obviously, cable faults are quite common as far as computer networks are concerned. Rather, talking about the classification of area, by geography, the network is usually divided into PAN, LAN, WAN, MAN, and CAN. You must have heard about LAN and WAN, at least. These are the two that are quite common. But obviously, we have PAN, MAN, and CAN. And we're going to talk about that as well. Coming up with LAN, LAN is a network which is first, most important of all, it means the local area network. And as the name suggests, it is designed to operate over a small physical area, such as an office, factory, or a group of buildings. The local area networks are easy to design and troubleshoot. The exchange of information and sharing of resources becomes easy because of LAN. In LAN, all machines are connected to a single cable. This is very important. The different types of topologies such as star, tree, bus ring can be used for making a local area network. It is usually a privately owned network. This is what is quite common. And obviously, it's not necessary, but usually it's a privately owned network. Now, wide area network. When networks span over large distances or when the computers we connected to each other are at widely separated locations, a location area network cannot be used. A wide area network in that case has to be installed. The communication between different users of WAN is established using leased telephone lines, the satellite links, and similar channels. It is cheaper and more efficient to use the phone network for the link, right? Most WAN networks are used to transfer large blocks of data between its users. So you must have seen that, talking about the internet service providers, they usually use the telephone line, and then same telephone line is usually used for dispersing of internet through that main line. So this is what the meaning of this telephone line over here is, right? Next is the PAN that I've talked about a little while ago, LAN, WAN, and then I'm going to talk about the PAN now. So this is something I believe is new to most of you. This is the personal area network. A personal area network is a computer network that is organized around an individual person. It generally consists of a mobile computer, cell phone, a PDA. PAN enables the communication among these devices. It can also be used for communicating among personal devices themselves for connecting to a digital level network and internet. The PANs can be constructed using wireless or even cables. So that is usually, revolved around a single person. And then that person may be using mobile, telephone, cell phone, uh, the PDAs, sort of a connected network. That is a personal area network. Another one, I believe for most of you, this terminology is again new, and that is a campus area network. The campus area network is made up of interconnection of LAN with limited geographical area. For the limited geographical area, we have CAN, how the network equipment such as switches, routers, and the transmission media, that is optical fiber, etc., are almost entirely owned by the campus owner. So this is the thing that matters the most because, the equipment such as switches, routers, and media, that is owned by some campus owner. The campus area network is interconnection of LAN with limited geographical area. So it's not one LAN network. You can say a multiple LANs and owned by some campus that makes a campus area network. Another terminology, again, I believe is new to most of you, that is the metropolitan area network. It is in between LAN and WAN technology that covers the entire city. It uses similar technology such as LAN. It can be a single network such as a cable TV network or mirroring of connecting a number of LANs or a large network so that resources can be shared LAN to LAN as well as device to device. So you can say that MAN is in between LAN and WAN, and it covers sort of an entire area. For example, you talk about your city, it's a metropolitan city, right? So it has some kind of a metropolitan area network. And that would include a number of LANs uh, connected and making a web map. Right? So this picture actually is the depiction of LAN, PAN, WAN, CAN, and MAN. You can see that we have a LAN over here. A number of PCs are connected to this LAN network, the local area network. And then we have PAN. In PAN, we have, we just talked about that. This is a personal area network, and we're usually talking about a single individual in that case, right? So, for example, you're sitting in your lab and you're using, for example, you have a laptop in front of you, and you're using a telephone, and that telephone is connected to your laptop. For example, you have opened uh, the WhatsApp. You're sending messages over here, and you're looking at those messages in your PC. So both of these are connected to each other, and you have some kind of a. I'm also using right now a wireless mouse, and that wireless mouse is connected to this PC. And I have a printer that is connected to my PC. I have some other mobile or other kind of system that is connected to my PC. So this usually involves a single individual that is and having a number of devices connected to some kind of a central network, that is a PAN. Talking about the wide area network, we can see here that it is a LAN system, and that LAN system is connected to another LAN, to another LAN, to another LAN. So a number of LAN networks making a WAN network, and hence incorporating a much wider geographical area. Okay, coming to the campus area network, you can see that we have an internet and centralized router, a wireless access points, and then sort of LAN networks in between that, but obviously under the geographical area of some campus, that is campus area network. And then we have MAN, the metropolitan area network. In the metropolitan area network, again, you can see there is some kind of a LAN system and LAN, and we have another LAN and another LAN, another LAN network. And all of those are connected to some centralized MAN network, that is the metropolitan area network. So obviously, all of these systems are connected to some centralized system, that is the MAN. So keep in mind that this MAN is significantly different than this WAN. So WAN is a number of LAN networks and connected to other LAN network, so that it is covering a much wider geographical area. But in case of WAN, all of those LAN networks are not directly connected to each other, rather they are connected to a centralized server, that is a MAN network. So all of this thing is making a MAN network. Okay, so how to distinguish between LAN, WAN, and MAN? LAN is usually the ownership is in the private hands as far as LAN is concerned. It covers a much smaller geographical area. It is easy to design and maintain. The communication medium is usually a coaxial cable. The bandwidth is low because higher bandwidth is not the requirement of that. The data speed is high because we have smaller geographical area, and therefore the data speed is high. As far as wide area network is concerned, it can be private or public. The area is very large. The design and maintenance is not that easy, obviously, because you have to cover a much wider area. So obviously, the maintenance is not that easier. The communication medium is usually either the satellite links or PSTN, the public switching telephone network. That is the the PSTN telephone networks that we have. The bandwidth is usually high, and the data rates are usually slow, right? Slower compared to LAN, that is. It's not low. You cannot say that low is sort of a generalized word. It is with reference to LAN. Talking about the MAN can be private or public. The geographical area is moderate. The design and maintenance is obviously not easy. The communication medium can be coaxial cables, PSTN, optical fibers, cable, wireless system. The bandwidth is moderate, and the data speed is also Okay, so you need to distinguish between LAN, WAN, and MAN, and this is obviously the best depiction of that, right? So talking about the geographical, in terms of geographical area, that has the much lesser or the lowest one in terms of geographical area, right? LAN comes after that, CAN after that, MAN after that, and WAN obviously has the largest of all in terms of geographical area, right? Okay. Network classification by their component role. So if you want to classify the network, right, in terms of their component role, so it is then divided into two parts. That is the peer-to-peer network, and the other is the client-server network. For the peer-to-peer network, in peer-to-peer network, each computer is responsible for making its own resources available to other computers on the network. Each computer is responsible for setting up and maintaining its own security for these resources. Also, each computer is responsible for accessing the required network resources from peer-to-peer relationships. Peer-to-peer network is useful for a small network containing less than 10 computers on a single LAN. In peer-to-peer network, each computer can function as both client and server. The peer-to-peer networks do not have a central control system. There are no servers in peer network, and peer networks are amplified into home group, right? So you can see this is the peer-to-peer network. So we have computers that are interconnected to each other, right? And we will shortly see how this is different to a client server network. So in the peer-to-peer network, we don't have a centralized server as we see in the server-based system that we will shortly see, right? The advantages are it is less expensive in terms of the hardware. It is easy to administer. No NOS are required. It is more built-in redundancy, easy setup at low cost. And with regards to the disadvantages, it is not very secure. No central point of storage or file archiving. Additional load on the computer because of resource sharing. All right, so there was sort of a delay. Okay, so I was talking about the advantages and disadvantages of peer-to-peer network. The advantages are that it uses less expensive computer hardware. It is easy to administer. No NOS is required. That is, no network operating system is required because every computer is, directly connected to the other computer. So you don't need to have a dedicated network operating system. There is more built-in redundancy, right? Because you can see that it appears to us that it is quite redundant, right? Because since each computer is connected to other system, so there is, quite possible that there would be, network collision between the computers. So it's sort of redundant, right? The easy setup and low cost is the other advantage of that. With regards to the disadvantages, it is not very secure. There is no central point of storing or file archiving because you don't have a central server. You don't have additional load on computer because of resource sharing, right? Because since source is being, the resources are being shared, so you don't get some additional load on the computer. It is hard to maintain version control, right? So, since every system, it is not, it's quite possible that specifications of different computers would be different. So it's hard to maintain the version control within the network. So you can see that on the left-hand side, we have a server-based system where we have a dedicated server and, computers are connected to that server. Whereas in case of the peer-to-peer network, each computer is directly connected to the other computer. So this computer is connected to this one, this, and similarly for the other computers as well. Client-server network. In the client-server network relationship, certain computers act as a server and act as a clients, right? So certain computers act as client and some computers can act as server. A server is simply a computer that available the network resources and provides service to other computers when they request it. A client is the computer running a program that requests the service from that particular server. The local area network is based on client-server network relationship. A client-server network is the one in which all available network resources such as files, directories, applications, and shared devices are centrally managed and hosted and then are accessed by the client. The client-server network are defined by the presence of servers on a network that provides security and administration of the network. So obviously, you have a dedicated sort of a control mechanism over the other PCs that are within the network, right? That is more secure. The advantages, the first and foremost, is it is secure, it has a better performance, there is centralized backup, and it is reliable. With regards to the disadvantages, it requires professional administration, more hardware intensive, more software intensive, and expensive dedicated software is required for that as well. Let's talk about the types of servers. For the servers, we have file server, print server, application server, the message servers, and the database server. The file server, these servers provide the services for storing, retrieving, and moving the data. A user can read, write, exchange, and manage the files with the help of file servers. The print server is used for controlling and managing printing on the network. It also offers the fax service to the network users. The application server, that's expensive software and additional computing power can be shared by the computers in a network with the help of an application server. In case of the message server, it is used to coordinate the interaction between the users, documents, and applications. The data can be used in for radio, video, binary text, and or graphics. For the database server, it is a type of an application server. It allows the users to access the centralized strong database. So that is a database server. So we have these kinds of different servers. Okay, now coming to a sort of a different subtopic, that is a transmission media. For the transmission media, we have two main categories. One is the guided. The guided include the wire and the cables. And then we have unguided, which include the wireless transmission, for example, radio, microwave, infrared, sound, sonar. We will concentrate on guided media. The twisted pair cables, that includes the unshielded twisted pair cable, the shielded twisted pair cables, coaxial cables, fiber optic cables. For the twisted pair cables, if the pair of wires are not twisted, electromagnetic noises from, for example, motors will affect the closer wire more than the further one, thereby causing errors. So you must have seen that, the twisted pair cables, obviously, I believe everyone of you must have seen that the cables are usually twisted. So if they are not twisted, the electromagnetism comes into play and the electromagnetic noise from the motors will affect the closer wire more than the further one, thereby causing errors, right? So this is sort of a noise source. We have some sender and we have a receiver over there, right? So the total effect of the noise that is nullified courtesy of this mechanism of twisting the cables. Okay, the unshielded twisted pairs, typically wrapped inside a plastic cover for mechanical protection. The plastic cover is basically for the mechanical protection. A simple untwisted pair cable with 5 unshielded twisted pair of wires can be seen over here. We have twisted pairs inside. And then we have, you can see over here, we have insulator and we have a metal. So this is the metal. Obviously, when you, rub off this insulator, you will get access to the metal that is inside this insulator. And over here, we have twisted pair where we have 5 pair of wires. Obviously, it all depends upon the type of application that it is being used for. This is the untwisted, unshielded, twisted pair, right? So we were unshielded, the twisted pair, right? So that was a twisted pair. This is also twisted pair, but unshielded twisted pair, where there is a wrapping for the mechanical protection, and then we have twisted pairs inside, and 5 of these can be seen over here. Okay, the next thing is the shielded twisted pair. The shielded twisted pair are similar to unshielded twisted pair cables, except there is a metal foil or braided metal mesh cover that encases each pair of insulated wires. So we have a plastic cover over there again for the mechanical protection. Then we have a metal sheet, and then we have an insulator and a copper inside. We have an insulator and a copper inside. So obviously this is twisted, but this is also shielded, right? So there is a metal foil or a metal mesh cover that encases each pair of insulated wire. So for each pair, we have sort of a, apart from this mechanical protection, we have sort of electromagnetic protection courtesy of this metal mesh, that is the metal sheet. Then comes the coaxial cables, a very famous one. Obviously, you must have seen these, uh, especially for engineering students. You must have seen these coaxial cables in different lab setups, and obviously in your homes as well. Coaxial cables, in general, coaxial cables or coax, that is also, in short form, it is called a coax, carries signals of higher frequency, usually around 100 kilohertz to 500 megahertz, the UTP cables. Outer metallic wrapping serves as a shield against noise. The second conductor that completes the circuit. So we have a plastic cover over there. Then we have these insulators. And then we have this outer conductor, that's the shield, and then we have an inner conductor. So you know that, yeah, the famous Gauss's law. You must have studied that, where you talk about the flux and the movement of the flux from inner insulator to the outer insulator, right? So that is quite famous. So obviously we cannot go into detail of that, but obviously, courtesy of the coaxial cable, there is no interference on the outer sides, and hence a very reliable for most of the application. Then we have fiber optic cables. The light travels at 3 into 10 power 8 meter per second in free space. And we know that is the fastest possible speed in the universe. So light slows down in the denser medium, for example, glass, right? So refraction occurs that interface with light bending away from the normal when it enters a less dense environment, right? You can see over here that we have this arrow, and then you can see this arrow is going uh, hence making a smaller angle with respect to this one. And eventually we have a critical angle where there is, you know, uh, total internal reflection comes into play, and all of this transmitted signal comes back and forth. There is no reflection or refraction on the outside. So we have total reflection within the this first medium, right? So there is no refraction, because refraction usually occurs at the interface. So with light bending away from the normal, right? So when it enters the lesser denser medium, right? But at a certain angle, which is the critical angle, all of the incident wave is reflected, and that is known as the critical angle, where we have total internal reflection. An optical fiber consists of a core dense material and a lesser denser material, that is the cladding. Simplest one is the multi-mode step index optical fiber. The multi-mode is multi-paths, where step index is the refractive index follows a step function profile. That is an abrupt change of refractive index between the core and the cladding. Light bounces back and forth along the core. Common light sources, for example, LED and laser. So we have, light going like this, up and down, up and down. We have total internal reflection. Okay, so how many computers are connected together? So to answer this question, we need to know the topology of the network. So here we have bus topology. We have talked about this earlier as well. This topology is known as the bus topology, right? So we have server and the computers connect to that, and they are connected via a single line. It's the bus topology. And then we have a star topology. So there is a central hub over here, and via this central hub, we have sort of a star kind of a network on one side and on the other side. And then we have a ring topology like this. This computer needs to connect with this computer. Obviously, it has to follow a certain path till the information is fed to the desired computer. With regards to the bus topology, it is simple and low cost, as you can see. A single cable called trunk, that is the backbone, or also known as a segment. Only one computer can send messages at a time. It's a passive topology. A computer only listens for not regenerated data. Since we have only a single line, so obviously only one system can get activated and pass on its information to the other system. In case of star topology, each computer has a cable connected to a single point. More cabling and higher cost. If there is more cabling over here. All signal transmissions through this central hub. If down, the entire network gets down. So if the hub is down, regardless of these four computers, if they are fine, it's becomes useless, because if the hub is down, the complete system would fail. Depending on the intelligence of hub, two or more computers may send messages at the same time. The two computers can send messages at the same time, courtesy of the star topology. Because with regards to the ring topology, every computer serves as a repeater to post signals. Typical way to send data, token passing. Only the computer who gets the token can send the data. So you can say that it's sort of a token gets to the next, and then it gets a token to the next. And so that, uh, only the computer who gets the token can send the data and pass on to the network. And that is why this word passing, right? The disadvantage is it is difficult to add computers. For example, we can easily add another computer to the bus topology or the star topology. But with regard to the ring topology, it is not easier to incorporate another system into the network. Okay. Moreover, it is more expensive. If one computer fails, whole network fails. Yes, the star topology, obviously, it was the hub that was most important. And the hub fails, the system gets down. Here, if any of the system gets down, the complete system would be failed, because the circuit will not get completed. And in case of ring topology, this overall loop has to get closed, right? So that is why the data is passed from one system to the other. So if any of the system is down, the whole system will get down. And that is it. That was all that was related to components of a computer network. And we have seen, the starting from the definition of the computer network, the types of, just a second, starting from the definition, and then the types of applications, uh, some basic information related to the computer network, the components of a computer network, the benefits, types of sharing resources, some other benefits, the disadvantages, and then the classification of area by the geography, local area networks, wide area networks, personal area networks, campus area, metropolitan, and then their depiction, the differences between all these kinds of networks, then the network classification by the component role that included the peer-to-peer network and the client server network, and the details of that, advantages, disadvantages, their depiction. Then we've talked about the servers, the types of the servers, and then the transmission media that included the twisted pair cables, the unshielded twisted pairs, right? So shielded twisted pair, the coaxial cable, the fiber optics, and then the topology that included the bus, star, and ring topology. So that's it from this topic of components of a computer network.